In this video, you'll learn how a car engine works. We will take you through the basic components of an internal combustion engine, including the cylinders, pistons, crankshaft, and camshaft. You'll see how fuel and air are mixed and ignited to create energy that moves the pistons, which in turn rotate the crankshaft and ultimately power the vehicle. We will also cover the role of the spark plugs, valves, and other critical parts in the engine's operation. Whether you're a car enthusiast or simply curious about how engines work, this video is sure to provide a fascinating glimpse into one of the most important and complex systems in modern transportation. The introduction slide sets the foundation for a presentation on how car engines work. It's important to understand that a car engine converts fuel into mechanical energy, which powers the vehicle. The most common type of car engine is the internal combustion engine or ICE, but there are other types of engines, such as electric, diesel, and hybrid. ICE engines are classified as either two-stroke or four-stroke engines, and they differ in the way they operate. By understanding the basics of car engines, we can appreciate how they function and how we can maintain them for optimal performance. This knowledge is useful for anyone who owns or operates a vehicle, as it can help with diagnosing problems and making informed decisions about repairs and upgrades. The intake stroke is the first of the four strokes in the combustion cycle of a car engine. It's important to understand that this stroke sets the stage for the combustion process by bringing in air and fuel to the engine. During this stroke, the piston moves down, creating a vacuum in the combustion chamber. The intake valve opens, and the air-fuel mixture is drawn in from the intake manifold. The air-fuel ratio is a critical factor for efficient combustion, and it affects the engine's power and fuel efficiency. A rich air-fuel mixture has more fuel than air, while a lean mixture has more air than fuel. The correct ratio is essential for optimal performance, as an incorrect ratio can lead to poor fuel economy, reduced power, and increased emissions. By understanding the intake stroke, we can appreciate how the engine takes in air and fuel and how the air-fuel ratio affects engine performance. The compression stroke is the second stroke in the combustion cycle of a car engine. During this stroke, the piston moves up, compressing the air-fuel mixture that was drawn in during the intake stroke. As the volume decreases, the temperature and pressure increase, leading to a more efficient combustion process. The compression ratio is the ratio of the volume of the cylinder when the piston is at the bottom of its stroke to the volume when the piston is at the top of its stroke. The compression ratio affects the engine's performance and efficiency, with a higher compression ratio leading to more power and better fuel economy. However, a high compression ratio can also lead to engine knocking or pre-ignition, which can damage the engine. By understanding the compression stroke, we can appreciate how the air-fuel mixture is compressed and how the compression ratio affects engine performance and efficiency. The ignition stroke is the third stroke in the combustion cycle of a car engine. During this stroke, the spark plug ignites the compressed air-fuel mixture, causing a rapid combustion process. The resulting flame front rapidly propagates, expanding the gases and pushing the piston down, creating mechanical energy that powers the vehicle. The ignition timing and spark plug gap are critical factors that affect engine performance and emissions. Ignition timing refers to the point in the combustion cycle when the spark plug fires, and it affects the engine's power and fuel efficiency. The spark plug gap refers to the distance between the center and ground electrode of the spark plug, and it affects the engine's ignition ability and emissions. A correct spark plug gap is essential for efficient combustion and reducing harmful emissions. By understanding the ignition stroke, we can appreciate how the spark plug ignites the air-fuel mixture and how the ignition timing and spark plug gap affect. The exhaust stroke is the fourth stroke in the combustion cycle of a car engine. During this stroke, the piston moves up, expelling the burned gases from the previous combustion cycle through the open exhaust valve. The exhaust gases flow through the exhaust system, which includes a muffler and catalytic converter. The muffler reduces the noise of the engine, while the catalytic converter reduces harmful emissions by converting them into less harmful substances. The valve timing and size of the exhaust valve affect engine performance and emissions. Valve timing refers to the opening and closing of the exhaust valve, and it affects the engine's power and fuel efficiency. The size of the exhaust valve affects the engine's ability to expel the exhaust gases efficiently. By understanding the exhaust stroke, we can appreciate how the burned gases are expelled from the engine and how the valve timing and size affect engine performance and emissions. The piston and crankshaft are two critical components of a car engine. The piston is a cylindrical component that moves up and down inside the cylinder bore, compressing and igniting the air-fuel mixture during the combustion cycle. The crankshaft is a rotating shaft that converts the linear motion of the piston into rotational motion, which powers the vehicle's wheels. The connecting rod connects the piston to the crankshaft, allowing the piston's linear motion to be transferred to the crankshaft's rotational motion. The crankshaft pulley drives the accessory belt, which powers the alternator, power steering pump, and other components. The proper functioning of the piston and crankshaft is essential for the engine to produce power and run smoothly. By understanding the role of the piston and crankshaft, we can appreciate how the engine converts the linear motion of the piston into rotational motion and how the accessory belt powers other components of the vehicle. The camshaft is a crucial component of a car engine that controls the opening and closing of the intake and exhaust valves. The camshaft is driven by the crankshaft via a timing belt or chain, which rotates the camshaft and opens and closes the valves in a precise sequence. The camshaft profile affects valve lift, duration, and timing, which affects the engine's performance and efficiency. Overhead camshaft, OHC, engines have the camshaft mounted above the cylinder head, which allows for better engine performance and efficiency because the valve timing can be more precisely controlled. The camshaft plays a vital role in the engine's operation, and by understanding its function, we can appreciate how it controls the intake and exhaust valves opening and closing, and how it affects the engine's performance and efficiency. The fuel system is an essential component of a car engine that delivers fuel to the engine. The fuel system consists of a fuel tank, fuel pump, fuel filter, and fuel injectors, all working together to provide a consistent and reliable supply of fuel to the engine. The fuel pressure and injection timing are critical factors that affect engine performance and emissions. Modern engines use electronic fuel injection (EFI) systems for precise fuel control, which provides better fuel economy and reduced emissions. The fuel system plays a vital role in the engine's operation, and by understanding its function, we can appreciate how it delivers fuel to the engine and how it affects the engine's performance and emissions. The cooling system is a critical component of a car engine that prevents the engine from overheating. The cooling system consists of a radiator, water pump, thermostat, and coolant, all working together to regulate the engine's temperature. The cooling system removes heat from the engine via the radiator, where the coolant is cooled by air passing over the radiator fins. The cooling system also heats the cabin via the heater core, which uses hot coolant to warm the air inside the car. A properly functioning cooling system is essential for the engine's longevity and performance, as an overheating engine can cause severe damage to the engine components. By understanding the cooling system's function, we can appreciate how it regulates the engine's temperature, how it affects the engine's performance, and how it contributes to passenger comfort inside the car. The lubrication system is another essential component of a car engine that helps reduce friction between engine components. The lubrication system consists of an oil pump, oil filter, oil passages, and oil sump. The oil pump circulates the oil through the engine, while the oil filter removes any contaminants that may be present in the oil. The oil pressure and flow rate affect the engine's performance and longevity, as inadequate oil pressure or flow can cause significant engine damage. The oil viscosity and type also play a crucial role in the engine's performance and wear, as using the wrong oil can lead to increased wear and poor performance. By understanding the lubrication system's function, we can appreciate how it helps protect the engine from damage and how it contributes to the engine's longevity and performance. Proper maintenance of the lubrication system is crucial to ensure the engine runs smoothly and reliably for years to come. Hi, I just wanted to take a moment to say thank you for watching my videos and supporting my channel. Your comments, likes, and shares mean the world to me and inspire me to keep creating content. If you haven't already, please consider subscribing to my channel. By doing so, you'll never miss a video and you'll be helping me reach more people with my message. I promise to continue providing high quality and engaging content that you love, so hit that subscribe button and join our community today. Thanks again for your support, and I will see you in the next video.